Okay, look at example 1. We have a surface of a quarter of a circle with a radius of 2 meters located with its top edge in here 1.5 meters below the water surface. So that is the case here, 1.5 meters below the water surface. And we're supposed to calculate the magnitude and direction of the resultant force on the upper surface. So we just need to calculate the resultant force applies from the upper surface. The force applies to here. So you can see here the pressure and the force from the water applies to here. And we can have like a horizontal and the vertical. And as you can see here, we have like a resultant force. F is a hypotenuse of the horizontal and vertical. So imagine this kind of like the direction is not given to us, but the only thing given to us is like the curved surface, which is in here. And we have a projected vertical projected surface is here, this one. And horizontal and the vertical one elements is FV is to calculate the volume or the weight here. To calculate the volume in this case, we need to just calculate the volume and use a formula rho GV. And horizontal one, as we learned before, is that you need to calculate the HG, the centroid of the surface, which is the middle of that, and the middle of that to the water surface. So you can see here the middle of this plane is like the 1 meters, because it's like the vertical projected area has got like a 2 meters because the radius is 2 meters, and half of this 1 meter, 1 meter plus 1 meter and 0.5 is like a 2 meter and 0.5 meters is like a HG. And we're just going to substitute in the formula and calculate FH. So let's go ahead with this calculation. For step 1, we also need to just calculate the area projected, vertical projected surface. The area of that one is equal to 2 meters. Because we calculate this for the gate per meter of the length of this surface, the area which is perpendicular to the screen is like a 1 meter. 1 meter is the length of that surface. Let's say it is like a gate, for example, 1 meter of the gate times the 2 meters. 2 meters like the from here to here. So this is the area. Area is like a 2 meters projected, vertical projected surface. So we can just have, and also we need to calculate HE. HE is like a 1.5 plus half of the 2 meters, 2 meters half, and the total is like 2.5 meters HE. If you substitute in the formula rho G HG A, rho is like 1,000 of the density of the water, 9G is a 9.81, and HG is a 2.5 times 2 meters square meters like area. The result is 49.05 thousand newtons per meter. Just bear in mind this is per meter of the length of the gate. Okay, so let's look at like the vertical force. Vertical force is like the weight or the volume. You need to just calculate the volume first of the area of above the surface, vertical. If you know, you can see here the dashed line here, dashed line here. We need to calculate the area in this section. So to calculate this one, we can just easily divide into 2 sections. One is a quarter of a circle, and the second one is a rectangular at the top of that. So it's easy to calculate all of them, both elements, very simple. So the formula that we have is the FV is equal to rho GV, and you can see here, and the volume can be easily calculated as a sum of a quarter of a circle. So 1/4 times pi to a square, pi r squared is like the area, and times 1, which is going to calculate everything for 1 meter of the length of the gate, plus this one, the volume of this kind of like a cube at the top is like the 2 meters times 1.5 meters times 1 meter of the length. So the total is like a 6.14 cubic meter per meter length. Okay, so that's like the volume. And the FV, you can easily calculate, substitute like 1,000 times 9.81 times 6.14, and the result is 60.23 thousand newtons per meter. So you just have like a FH and FV. So now it's time to calculate the resultant force. Resultant force based on the Pythagoras can be easily calculated. as the square root of sum of the squared value of the two elements or components. So fh squared plus fv squared, the sum of these two raised to the power 1 second. So you can factor 1,000 from both elements and take this out from the square root and take this out outside. Inside the bracket, you can write 49.05 squared plus 60.23 squared raised to the power 1 second. The result is 77.68 thousand newtons per meter, and the angle phi is equal arctangent of the ratio of the fv opposite, which is the fv, to the fh, the horizontal one. So the fv is like a 60.23 over 49, fh is like a 49.05, and the result in the angle is equal to 50.8 degrees, and that's like the resultant angle relative to the surface. So this is the example 1.